Hello coders, welcome to my video. So, have you ever written a C program that compiles perfectly but crashes at runtime? Or worst, it runs fine but gives completely the wrong output. So, in this video, we'll break down all types of errors in C from compile time to the runtime. And I'll show you the real debugging examples like system engineer will do. Okay. So, to understand the errors properly, we need to understand the build pipeline. So, what is that build pipeline? For example, we have a .c file and we have a preprocessor stage in which it's converted into the preprocessor form, and then the compiler will take that output and link all the object files into executable and goes into the runtime. So this is the build pipeline of a C program. Okay, so every stage can introduce different error types. So this is very critical if you're working on an embedded system. Okay, so whatever the error is caught by the compiler, that is the compile time errors, and whatever the errors are there at the runtime, that are runtime errors. Okay, so compile time errors will get when we are compiling our program to create a binary. But in case of the runtime error, we get a binary and we launch that binary as a process. Try to launch it as a process. So at that time, if some error happens, that is a runtime errors. Okay. So we'll completely go one by one to each of the errors to understand what this error is, and we'll have a practical approach and we'll see actually what compiler will complain, what is the string that the compiler will give as an error. Okay, so for example, we'll start first with the compile time errors. The first error is a syntax error, so this you already know. So if we miss some semicolon or any variable, or sorry, the type name change, so we'll get this compiler error. Okay, so it may be due to the invalid declaration as well. So for example, I have this C program. Okay, and I will remove this semicolon from here and I try to compile it. So if we compile it, we get an error. So let's understand this error. This is showing we have an error at 42 number, line number, and it will be expecting a semicolon before the return. So return is this, and we are expecting a semicolon. So for example, if I have, let's say if I take int a is equal to hello, and I try to compile this, so you'll get a different error which says, okay, it's a warning. Okay, initialization of int from character and make integer from pointer without a cost. So this hello is a pointer type, and we are allocating this pointer to a int variable. Okay, so this is not syntactically correct. So this warning will be given. So in compiler enforce syntax and type safety. So in production firmware, we often see we have some flags that we give. For example, we have hyphen wall and hyphen w error. So all the warnings are treated as errors. So if we do now, you will get the error this time, not the warning. Okay, so you will see this behavior in lot of embedded programs. Okay, so here you get another error as well, unused variable, because it is illegal, so it's not being used as well. So that's why it's complaining about that. Next is the semantic error. Okay, so what it does, it is due to the undeclared variables and type mismatch. So we already have this example of undeclared variables. For example, here we have int a and that is undeclared. So I'll do one thing. If I take a new variable b and I am not using it, okay, and if I compile it, you will see you will have this unused variable array. Okay, so if I won't use this flags, so we'll get maybe some warnings. Okay, so this is how this semantic error is there. Okay, so third type of error in compile time error is a linker error. So this linker error is very interesting. Okay, so for example, what I will do, I'll remove this and I have a function that is not declared here and maybe in some other file, and I'm externing it, extern void of function. Okay, so when I compile this, so when I compile it, you will see you will get a linker error which will show undefined reference to function. So this function is not been defined, and this is also a compile time error because compiler is uh, giving this thing, and we are not getting any executable for that. So once the compiler errors are finished, we'll get a dot out or any other binary which we are giving to GCC. Okay. So compiler here trust that the function exists, but when we compile it and at that linking stage, this fails. So next is our runtime errors. So it may be due to logical errors. And what are the logical errors? For example, we have some wrong formula. Okay. Then we have incorrect condition or some faulty algorithms. So if we take an example of logical, so I will remove this part. For logical errors, if I have a condition, if a is equal to 10, int a is equal to 20, okay, and we are getting this printf. For example, a is 10 and I have printf a is 20. I'll put it in else condition here. Okay, so so if you see here, we have value of a as 20. So it will check this condition, and if a is 10, it will go into this, else it will go to 20. So what happen if I save it and this done? Okay. So you get an a dot exe. So when you do a dot exe, sorry, is a dot exe, you'll get a is equal to 10. But here we are defining a is equal to 20. So here what we did was I just allocating the value or changing the value of a to 10. So this is always true and a will be 10 always. So this is some logical mistakes that is there. Next is after this logical runtime error, we have runtime faults. Okay. For example, I am device. So after these logical errors, the next error we are getting is a runtime faults. So these all are the types of this runtime faults. So to explain the runtime fault, what I will do, I'll go again here. Now, what I will do, I'll have an int star of pointer is equal to null. Okay, and here I am putting half p is equal to 10. I compile it, I am able to compile it. Okay, but when I run it, there is nothing. When I compile this code, I got a.exe. Okay, so if I am dereferencing it, so printf, I'll take pointer value is percentage b. Okay, and here I have star of pointer. If I save it and I again compile it and now I run it. Okay, so you got some crash. In spite of using this, if I have int a is equal to 10, comma b is equal to 0, and int c is equal to a divided by b. Okay, so if I do like this and save it, so you'll see unused variable c. So for that, what I will do, I'll do printf and value of c is percentage d. Okay, and here we have c. Save it. Again, I go there and compile. Now it's fine. A.exe, I got nothing. Okay, it means our this runtime error is there. So if I won't do this, and in spite of this, I'll take 19 and save it. So you get the value of C as 19. So if you are using this division by zero, it also got crashed. So that is a runtime fault. And we have stack overflow that you already know. So we are calling a function again and again. Still, we have a stack overflow. So for example, I have a function here and I just printf recursive. Okay, and I save it without any condition. I call this value. So I'll call function simple. So save it. Again, I compile it. Then I do a.a. So it got crashed. So there is a stack overflow due to this function calling again and again till the stack is overflowed. So this is all about this video. Let's see in the next video. Thanks.